Hey, we have here today another integral. This one's from the MIT Integration Bee 2022. This is regular season, problem number 2. We have the integral of ln 1 plus x over x squared dx. At first I found it pretty tricky because what I wanted to do is like a u substitution, noticing if our u was ln of x, the derivative of ln x is 1 over x. I thought I could use that, but I actually didn't really find a convenient way to use the derivative of ln x because we got this problem that we got a 1 plus x here, and it kind of defeats that strategy. So what I wanted to do instead was integration by parts, and we'll use the DI method, and we're going to split this into two functions. We'll look at it as ln 1 plus x times 1 over x squared. I can differentiate ln 1 plus x, and I can integrate 1 over x squared. Then taking a derivative of ln 1 plus x is just going to be real easy, 1 over 1 plus x. And then the integral here, we can look at this as x to the minus 2. Integrating this is going to be minus 1 over x. So right away we've got part of our solution right here. So let's just write that down. While I remember it, we'll have our minus 1 over x, natural log 1 plus x. And this piece here, I'll multiply this together. I'm actually not going to multiply it in though. Minus times minus is plus. We're going to have the integral of dx over x times 1 plus x. And for this integral I'm going to use partial fractions on this. And it's not going to be too bad because we have two linear terms, so this should go pretty quick. What I'm going to do is write this as a over x plus b over 1 plus x. And I'm just going to do this out the long way, so let's just see how this is going to look. What we want to do here is we get it back to our common denominator. So if I multiply here by 1 plus x, and I multiply here by x, then this numerator has to equal 1. So if I multiply this all out, we have ax plus a, distributing this in, plus bx equals 1. Well, what that implies is a plus b is going to equal 0, and our a has to be equal 1, just equating the like terms. But if a is 1, then b must be minus 1 for this expression to be true and 0. So coming back to our integral over here, if our a is 1 and our b is minus 1, we can clean this up and put this in a form where we can integrate it. Okay, so with a quick rewrite, we have our a equals 1 here, and this is our minus 1 from the b. Now this is going to be easy to integrate. Integral of dx over x, this is going to be just ln x minus, and the integral here, this is just going to be ln 1 plus x. And now in order to finish this off, all I need to do is bring down this first piece. We don't want to forget that. And so this down here is going to be our solution. But I'm just going to try to simplify it a little bit. For our answer, I think we'll bring down our ln x. I think what I'll do is, because we have this in common, I'll bring out a ln 1 plus x, but then factoring that out, we're going to have just the 1 from here, and then this is going to be, because we've already factored out minus, this is going to be plus 1 over x plus c, and that's it. Not too hard, but it made us do partial fractions and integration by parts in a problem, so that was pretty good. We'll stop it there. Thanks everyone for watching today. Have a great day.